Hello guys, welcome back to this channel. In this video, we'll discuss GATE 2024 Linear Algebra problem number 35 and its complete solution. After that, we'll see what are the core concepts that are involved behind the problem. And at last, I have attached some few practice problems for you to solve. So, let's begin. So the problem is, consider the 3 cross 3 matrix M. So this is given 3 cross 3 matrix. We need to find the determinant of m square plus 12m. Okay, so let's moving on to the solution. What we have is, we have m, which is a 3 cross 3 matrix, and we need to find the determinant of m square plus 12m. Okay, so if we carefully see this term m square plus 12m, if we factorize this term, then this can be written as, taking m as common, then m plus 12 into I. Okay, this is the important part. Okay, so while factorizing m square plus 12m, we can write this as m into m plus 12 into I. Okay, this is a very important part, and we can't write this m into m plus 12. Why? Because since we can't add a matrix with one scalar quantity. Okay, for addition of this matrix, this 12 will also be converted into matrix, hence we use this 12 into I for converting this 12 into matrix. Okay, this is a standard procedure. So what we do is, this can be factorized as m into m plus 12 into I, where the size of I is same as that of m. Okay, so what we have is, now this can be factorized as m into m plus 12i, m plus 12i. Okay, this is done. Now this what we need to find the determinant of m into m plus 12i. So this is in form of determinant of a into b. Okay, and we know that the determinant of a into b can also be written as determinant of a into determinant of b. So we can write this determinant of m square plus 12m as determinant of m into determinant of m plus 12i. Okay, so we know the matrix M. This is a matrix M. If we find the determinant of M, then we get the determinant of M is 0. Okay, determinant of M, if we find, we get determinant of M is 0, and hence this term is 0. Therefore, the determinant of M square plus 12M will also be 0, which means hence determinant of M square plus 12M is 0. So the correct answer is 0. Okay, now let's moving on to the core concepts that are involved behind the problem. So the core concept is the matrix factorization. Okay, this one. So this we have this m square plus 12m. So this can be factorized as m into m plus 12i. Okay, this can't be written as m into m plus 12. Okay, why? Because this is a scalar and this is a matrix. We can't add matrix with a scalar quantity. We need to make this scalar into matrix so that we can add this. Okay, here I should be of same shape as m, because we can add only matrix of same shape. Okay, so this is the important part. So matrix factorization. Okay, if we take this matrix out, then we need to replace this with I. Okay, because we can't add matrix with scalar quantity. Okay, now second one is, the determinant of a into b is equal to the determinant of a into determinant of b. Okay, this is also an important part. And the determinant of a plus b is not equal to determinant of a plus determinant of b. Okay, this is also an important thing. This is not equal to. Okay, this is not true in case of addition, but this is true in case of multiplication. Okay, now moving on to the sub practice problems. First one is, let A be an n cross n matrix such that determinant of A is 0. Okay, what is given? A is an n cross n matrix and determinant of A is 0. We need to find what is the value of determinant of A square plus I. Okay, the options are 0, strictly negative, strictly positive, or can't say anything. Okay, so if we carefully see determinant of A square plus I. Okay, so what is given? A determinant of A is equal to 0, which means the eigenvalue lambda, and eigenvalue of A, one of the eigenvalue is 0, and we can say some eigenvalue n minus 1 eigenvalue will be non-zero. Maybe, okay, will maybe non-zero, can be 0 also. At least one of the eigenvalue will be 0, we can say. Okay, now if we see let the eigenvalues of A, let's say, will be lambda 1, lambda 2 dot, dot, lambda n. Okay, then what is the eigenvalue of a square? Will be lambda 1 square comma lambda 2 square comma lambda 3 square dot, 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 lambda n square. This we know. Okay, this is always greater than or equal to 0 because square terms is there. Then if we see the eigenvalues of a square plus I will be, this will be lambda 1 square plus 1 comma lambda 2 square plus 1 up to lambda n square plus 1. Okay, this will always be greater than 1. Okay, greater than or equal to 1. This will always be greater than or equal to 1, and hence we can say that all eigenvalues of this term is always positive, will always be positive, and hence the determinant is just the product of eigenvalues. Now all eigenvalues are positive, hence determinant is strictly positive. Okay, here hint is given. We know the determinant of a is equal to 0, which means at least one value of a, eigenvalue of a is equal to 0. And let's say eigenvalues of a is lambda 1, a are lambda 1, lambda 2, or lambda n, then eigenvalues of a square plus I can be written as this. This is always greater than 1. Okay, this is always greater than 1. Always greater than or equal to 1. Okay, always greater than 0 or greater than or equal to 1. And hence we can say that the determinant of this term a square plus I will be always strictly positive. Okay. Now the second problem is, let A be a singular matrix. Okay, singular matrix means the determinant is 0 or at least one eigenvalue of A, one eigenvalue lambda is equal to 0. We need to find which of the following is or are necessary singular: a square plus a plus I, or a square plus I. So let's see a square. We know that A is a singular matrix, which means at least one eigenvalue of A, lambda 1, let's say, is equal to 0. Okay, then if we check a square, and then eigenvalues of a square will be lambda 1 square or lambda 2 square, lambda n square. Okay, if lambda 1 is equal to 0, which means lambda 1 square will also be 0, and hence one of the eigenvalue of a square must be 0, which means a square is also a singular matrix. Okay, if we see a square plus a, this can be written as a into a plus I. Okay, using matrix factorization. Okay, but we know that the determinant of a into a plus I will also be 0. Why? Because we know that the determinant of a is 0. Okay, and we can split this as determinant of a into b, and we know that determinant of a into b is equal to determinant of a into determinant of b. Okay, so we know that determinant of a is equal to 0, and determinant of a square, which is determinant of a ka whole square, is equal to 0. So the first one, a square, is singular. A square is plus a is also singular. If we see a plus I, okay, so let's say the eigenvalues of a will be lambda 1, lambda n, then eigenvalues of a plus I will be lambda plus 1, okay, lambda 2 plus 1, lambda n plus 1. Okay, so let's say all the eigenvalues of a is either 0 or greater than 0, then the eigenvalues of a plus I will not be 0. Okay, so this is not necessary singular. And a square plus I, okay, a square plus I, this we have already seen, this is not singular matrix. Okay, why? Because the eigenvalues will be lambda 1 square plus 1, lambda 2 square plus 1, this will be always greater than 0, and hence this matrix is not singular matrix. So the correct option are A and B. Okay, A and B are correct. Thank you. If you have any doubt, you can let us know in the comment section below. And for more such content, don't forget to subscribe. Thank you.